solve this exponential, right, what was the first step? Isolate. So in this case, the exponential, right, is this. Right, that's the exponential that has to be isolated. So what's with it on that side of the equal sign that we need to get rid of? The 4. So we would subtract 4 from both sides. So now we've got 6 to the 2x equals 21. Now remember when we first learned the exponentials, we learned exponentials are a times b to the x. If there was another number in front of that, you would have to divide by that number. It's not part of the exponential that we're isolating, right? When we say exponential, we mean the thing that's being raised to the power. So only the 6 is being raised to a power. So that's what has to be isolated. Okay, now that it's isolated, what was the second step? Take a logarithm of both sides. So let's take log base 10, because that's on the front of your calculator. We'll do a log base 10 of both sides. Log of 6 to the 2x equals log of 21. Right? And basic algebra says if I do it to one side, I got to do it to the other side. Now, why don't I have a base of 10? Because it's assumed, right? When you don't see a base, you think that it's 10. Okay, now, by the power property, I can simplify this, can't I? What could I do? Take the exponent and move it out front as a coefficient. That's the power property. So this is now 2x times the log of 6 equals the log of 21. Right? By doing that, we've got the x down where we can solve for it, right? We can't solve for it when it's stuck in the exponent, but because of the power property, we were able to pull it down at the level where now we can isolate it and solve for it, right? So what do I need to get rid of now? So we've isolated x on the left. The log 6, definitely you got to divide by that. Well, which will give us this. 2x equals the log of 21 over the log of 6. Right, still not done. No, you cannot. You cannot use a quotient property here, right? Quotient property is when you have a quotient inside one logarithm, not a quotient of logarithms, right? So, but what do I have to do to isolate the x? Divide by 2, right? It's not x yet, it's 2x. So x equals log 21 over 2 log 6. Right, now all of that can be put in the calculator. Log 21 over 2 log 6. I got this too far over. I'll do it here. We can just use this as the screen. Clear. So, you know, it's real important that you actually do this. You know, take out your calculator and really do it and really make sure you're getting the right answer. Because it can be a really small calculator error that's throwing you off. For example, when I put in log 21, that log, and now I put in the 21, the calculator put in the left parenthesis. If you don't end the left parenthesis, it's going to put what follows in that first logarithm, which is in the numerator. It won't be right. So by all means, you know, you got to end the log of 21 by putting a right parenthesis. Okay, then you're going to divide, and because you've got 2 factors in the denominator, 2 times log 6, that needs to be in parentheses. Right? If you didn't put parentheses, it would divide by 2 and then multiply by log of 6. So you got to say divided by parentheses 2 log short log 6. And again, now I've got to end the 6, the logarithm, and then end the denominator. So that's what it should look like. I think I got it. like that. Log 21, you can't see the whole thing, divided by 2 log 6, enter. You should be getting 0.8496. Right, that was rounded to 4 decimal places, mostly because that's what they did in the book. In my teacher's edition book, they did round to 4 decimal places. And I have to say with logarithms, because remember what I said, logarithms are exponents. And it's very, the value of something very sensitive to what's in the exponents. It would make a difference if I changed that, by only having 3 decimal places or 2. So they show a little bit extra there, 4 decimal places.